Hello everyone, welcome to part 7 of class 10 science. We are studying chapter 11 physics, that is human eye and colorful world. Friends, this will be our last part of this chapter series. In this chapter, we focused on three major phenomena which is occurring in this atmosphere on earth, right? Out of that, the first one was dispersion, right? So we studied dispersion, what is dispersion, and based on dispersion there were some natural phenomena like spectrum, some experiment of recombination as well, rainbows, that were related to dispersion. The next atmospheric phenomena that we studied was atmospheric refraction, and the related phenomena were twinkling of stars. We studied why do not the planets twinkle. Then we studied advanced sunrise and delayed sunset, right? So dispersion and atmospheric reflection are the two phenomena that we studied. Now today in this video we will study the third phenomena, a colorful phenomena, that is called scattering of light, right? See, the interplay of light with objects around us gives rise to several spectacular phenomena in the nature. So in this video we will talk about those specific phenomena, right? Before we start the video, in the previous video, that was part 6 video, I told you that whosoever will comment the questions, the answers of the questions which I asked in the last video, I'll give you a shout out. So these are few names which I found out that they commented very fast. Few names that I couldn't find, but I have written their YouTube account names, right? So congratulations all of you. Those viewers which still are commenting less or not commenting, please be active and let us make this session interactive, right? So moving on to the today's topics. Today's topics is, first of all, what is scattering of light. Next, we will revise a topic that you have already studied in standard 9, that is Tyndall Effect, blue color of sky, color of sun at sunrise and sunset. So these few basic phenomena are related to scattering, so we will study one by one. Moving on to the first topic, that is scattering of light. Now, the scattering of light is defined as the deflection of light by minute particles and molecules in all the directions, right? As you know, the Earth's atmosphere, it is a heterogeneous mixture of many different particles. These particles usually are not visible, right? So they are known as fine particles or minute particles. But even though they are small, they do deflect the light by some angles or some distance, but they do deflect the sunlight, right? And this deflection is nothing but scattering of light. But what happens due to scattering is different constituent colors are scattered in different directions, right? So we can say that the color of the scattered light depends on the size of particle. Now how they depend on the size of particle? Small size particle, they scatter the light of smaller wavelength. So one example of smaller wavelength light I have told, blue, right? And the bigger particles, they scatter large wavelength light, that is towards red, right? And if there are still larger particles, they will scatter white light. Okay, so small size particle, small wavelength light, big size particle, large wavelength light. Clear? So that is why I told the color of scattered light depends on the size of particle. Now how is scattering visible? So scattering of light, that means light goes into all the direction. Whichever color rays are scattered and enter our eyes, we will see that specific color. See, if blue color is scattered and that color is coming to our eyes, we will see that thing as blue. If red color is scattered and coming to our eyes, we will see that object as red. Clear? So scattering of light is the only phenomena which is related to few basic processes like Tyndall effect, why sky is blue, why sky even appears dark, why clouds are white in color, why sunrise and sunset, at the time of sunrise and sunset the color of sky changes. So they are all related to scattering of light. Now let us revise Tyndall effect as it is also related to scattering. Now scattering of light when they pass, the light beam when they pass through colloidal solution, the path of that light becomes visible, and this phenomena is called Tyndall effect. Now you studied that there are many types of solution. Out of that, one was, or mixture, one was colloidal particles. In that, the particles as compared to true solution, the particles are little bit big, even though they are not seen. But if you pass a light beam of light through those solution, you can actually see the path of light. So this process was discovered by Tyndall, right? So that is why we call it as Tyndall effect. Okay. Another example of Tyndall effect which you can find in nature is when sunlight enters a smoke filled room by a small hole, the path of beam of light will become visible. Another example you can see in a dense canopy of forest where trees are very close to each other, right? Where leaves, branches are very close to each other. Very small space is there, so that sunlight that enters in that dark, dense canopy. So the path of sunlight that is coming down is visible. So that is Tyndall effect. Even in case of mist or smog, we can see this phenomenon. So let us see how it happens, how it is visible. You see, here on the left hand side, there are two containers in which different solutions are filled, and here you can see a torch, right? So here in the first one on the left hand side, true solution is there. So that is why no light is scattered, because the particles are very fine particles, right? So they do not scatter. But over here you can see it is a liquid mixture only, but the particles here are colloidal particles. That is why even though they are not visible, but if the light is entering, they scatter the light. So that is why the path of light is visible, right? So this phenomena in which the path of light is visible is called Tyndall effect, right? So even it is seen in colloidal solution, but if you see over here in nature as well, clouds, atmosphere, you can see the Tyndall effect. You can see top to bottom, the light rays, the light path is being visible. So this is a natural phenomena which you can see quite often. Clear? Here you can see the natural example of scattering of light which we just now talked about. You see a dense canopy of forest where leaves and branches are so close. So if the sunlight is entering due to the dust particles, you can actually, the dust particles, they scatter the light. That is why you can see the path of light coming below, right? So this is nothing but Tyndall effect. Also we talked about when in a smoke filled room, in a dusty room, when sunlight enters, the path of light becomes visible. So these all are example of Tyndall effect, but Tyndall effect is ultimately related to scattering of light, right? Why we are studying these figures? Because these figures are real life examples of scattering of light that we see quite often. Okay. Now the next most important part is blue color of sky. See, the molecules of air and other particles in the atmosphere have very small size, right? We can say they are fine particles. Okay. Now these are more effective in scattering the light which are of smaller wavelength, right? So that is why the smaller wavelength light are scattered more. Why? Because there are fine particles in the atmosphere. Clear? So you see, we have already talked that small particles, smaller wavelength light, and big particles, bigger wavelength light. But atmosphere consists of mostly air and other fine particles. So they effectively scatter light of shorter wavelength, that is of blue color. Clear? Now if you see the sun directly overhead, if you see when the sun is overhead, you won't see blue color sky, right? If the sun is overhead, you see that as almost white or pale yellow. Okay, but if usually in other cases when the sun is not at overhead, not in the afternoon, but except afternoon and evening and morning, usually blue colored light is scattered the most. That is why all of us we see the sky as blue. Clear? So the smaller particles, they effectively scatter light of shorter wavelength at the blue end. So these scattered blue light, they enter in our eyes more. So that is why sky appears to be blue most of the time. Clear? Now something extra that can be asked in a short question, that is, why does sky appears dark to passengers who are flying high? Right? So the answer lies over here, that is also given in the textbook, that at great altitudes, altitude means height, at great heights, scattering phenomena becomes less. Why? Because near to the surface of earth there are more dense particles, more gases, but as you go at height, the density of air will decrease, so particles will decrease, so scattering phenomena will decrease. That is why sky appears dark to the passengers, right? Now one question I'm leaving it for you, also given in the textbook. Find out the answer and write in the comment why danger signals are of red color. Okay, why danger signal are chosen specifically, why they are red. So this answer I am expecting in the comments. You have more question, wait for it. Now the last topic, that is reddish color of sun at sunrise and sunset. You see, I have given a illustration of how the sky looks, how the sun looks at the time of sunrise and sunset. Now the answer is very easy. Also there is a figure given in our textbook, but uh, you have to ignore that figure, or you have to change the figure a little bit. Why I am telling? When the sun is at overhead, the light has to travel shorter distance, right? So in that case, less blue color is scattered, and at that time the sun does not appear like overhead when it is afternoon. At that time, less blue color is scattered. That is why we can see that as white or pale yellow, right? Exactly in the afternoon. But when the sun is near the horizon at the time of sunrise and sunset, the light has to travel more distance, right? So light from the sun at the time of sunrise and sunset, when the sun is near the horizon, it travels more distance before reaching our eyes. Okay, now during this, when at the time of sunrise and sunset, the light, when it is traveling more distance, the blue light is scattered away. Okay, the blue light is scattered away, and whichever light is less scattered, like the red, the orange, they travel far distance and reaches to our eyes. So whenever at the time of sunrise and sunset you are looking at the sun, only the red end colors, they are reaching to your eyes. That is why at the time of sunrise and sunset you see the sun or the sky as reddish yellow or orange. Clear? So this is the answer. Now the chapter ends over here. The scattering phenomena and related process ends over here, right? But you have a question. You see, this personality belongs to India. He has got a very big prize for his discovery related to scattering of light. You have to identify the personality and you have to tell what relation he has with our today's topic, right? So please watch the video carefully and then only you comment. Don't uh, be in a race to comment first. You are skipping the video, you are directly going to the question and then you are commenting. Please don't do that, right? And whenever you are commenting, please write your name below. Okay, so that's it for today. We will meet with a new chapter in the new session. That's all for today. Thank you.